Okay, so welcome back. In this video, we're going to talk about C#. I haven't done a C# tutorial in a while. And we're going to talk about timers and events and delegates. And the way we're going to do this is we're going to simulate and model a real-world device, an engineering device called a relay. And you can see here down at the bottom right, I've got an image of a typical relay. And it's basically an electronic device that performs a function. And the function is to detect if the current, the electrical current in a circuit exceeds a certain value. And if it does, it starts a timer. And if the current doesn't go back to normal by the time the timer times out, it will open a circuit breaker to disconnect the circuit and disconnect the overload or short circuit or whatever's causing the increase in current. Okay, now you've got a device like that probably in your house where your electric service from your utility comes in, and it's a circuit breaker on a panel probably in the basement, and it detects if you've short-circuited your wires in your house or there's an overload that exceeds a certain value, and it will open the circuit breaker and cut the power to your circuit. So as an engineer, I find this is the best way to really understand things like C# concepts and object-oriented programming. A lot of times with C# tutorials, you will see people talking about kind of generic person classes that don't really utilize the real great functionality of object-oriented programming in C#. And if you model a real-world device, it makes it real and it makes it easier to understand, I think. And it shows how to actually use those concepts to simulate or model a real-world device. And so that's what we're going to do here. And here I've got basically a block diagram of the relay. And this particular relay does a fairly simple task. It takes the current or the amps measured on the circuit that's feeding whatever load you have, and it compares that in this block, which is called a fault detector. It compares that with a value that you input, which is called a pickup setting. So for example, if the current on the circuit at a particular point in time is, say, 5 amps, and you set this to detect anything over 2 amps, then it's going to say, hey, wait a minute, I've got more current than I want. I want only 2 amps, a maximum, and I'm getting 5 amps, so hey, we need to do something. So it's a simple comparison to what you have told it, and if it exceeds that value, it starts the timer. And the timer will start timing, and it will time for whatever amount of time you have told it to in this time delay setting. So for example, you might give it 5 seconds and say, okay, I've got an overcurrent, I've got a fault detected, so start timing for 5 seconds. And if that overcurrent hasn't gone away in 5 seconds, I need to open the circuit breaker and disconnect my circuit. All right. So it's a fairly simple set of functions that it performs. Now, let's think about how we would apply this to C# or object-oriented programming. So if you look at this model block diagram of a relay, you can see, well, there's 2 main functions. It performs one function to check if the actual amps in the circuit is greater than what you expect in terms of this pickup setting, and another one which is a timer. And it gets an input from this fault detector. If there's a fault, it starts the timer, and the timer times for the time delay setting and then sends a signal out. So you can start to see in terms of object-oriented programming, you've got a class of a relay, and it contains some properties, which is what's the pickup setting that you've entered, and what's the time delay setting, and then it's probably got some status indicators, some booleans. Is the fault detector picked up? Did it send a trip is the timer timing, is in the process of timing. So you can start to see how you would apply a class to this. And it's got two main methods. One is the fault detector and one is the timer. Okay, so here you can see how beautiful this is in terms of object-oriented programming, where you've got a physical device that has properties and methods, and it really makes it very intuitive to set this up in an object-oriented environment. And you can have, multiple relays all have the same characteristics. Now, unfortunately, you'll see, I've seen videos of people who downplay the object-oriented programming concepts and say they're ridiculous and they're a waste of time and everything. From an engineering perspective, I think that's absolute nonsense. I mean, here you've got a perfect example of a real-world object that fits perfectly into object-oriented programming concepts. So we're going to use that to model this relay. So now we've got the properties, we've got the methods. Now we're also going to have to think about having one more functionality here, which is a global time step to check the input current, and if it drops, you reset the timer, okay? So you don't just, determine if there's a fault and start the timer and time out. The purpose of the timer is to say, well, if the current drops back to normal in this time delay, I don't have to go to the trouble of tripping the circuit. I can just ignore it and keep operating, okay? So we also need not only this timer, but we need another global time step timer to every, tenth of a second or something check to make sure that this is still picked up, this fault is still sensed. And if suddenly the overcurrent goes away, you can reset the timer and not trip, okay? So that tells us not only do we need to have a relay class with functionality and properties, but we also need to have a system timer, a system time step timer, which we might want to consider as a separate class, and then have this relay subscribe to the events of this time step timer, and every, say, tenth of a second as this thing is timing out, just check, hey, is the fault detector still picked up? And if suddenly it's not, we can stop the timer and stop the trip. Okay, so now we're starting to see we're going to have a relay class, we might have a system timer class, and we're going to have some events and delegates in this to subscribe to this. Now, I previously, a while back, I prepared a series of 3 videos talking about events and delegates. It's a fairly counterintuitive in some ways and complex subject. So I encourage you to look at those 3 videos where we talk about the concepts in real world terms to try and better understand this concept of events and delegates. Okay, so here I am in Visual Studio, and I've started a simple console application. I'm not going to go through how to do that. I'm going to assume you know how to start up a Visual Studio project. So this is a C# console app. You can do a Windows Forms or a WPF, whatever you want. And this has got basically 3 components. And you can see up here on the tabs, I've got my program, my main program, static void main. I've got a relay class, which basically models this we were talking about before. And I've got a system timer class, which sets up the timer to check the relay at every tenth of a second or whatever to see if anything has changed and whether you need to shut off the timer. Okay, so fairly simple. I've got the main program, the relay, and the system timer. Now, what I like to do is keep my main program fairly simple, right? And move most of the functionality into classes, okay? And in this case, it's a great opportunity because a relay is a object, it is a class, and system timer, you can make that a class, you can make a static class, whatever. So basically, I've got these 3 components, And you can see here in the main program, all I'm doing is I am instantiating, the first thing, I am instantiating the relay class. I'm making one relay. And then I am instantiating the time step timer. And what I've done here, if you're not familiar with regions, I basically have used a pound region and a pound end region to make a section of code that you can label and open and close like this. Makes it a little bit easier to see. So I'm setting up the relay, setting up the timer, and then all it does is it says, okay, I'm going to say that there is a fault. Fault detected is true, and then I go to the relay method and start the fault detector. So now let's go to the relay class. We'll click on the relay class, and as we said before, we expect it to have a couple methods, some booleans to indicate status, and also some properties, the pickup setting and the time delay setting that the user can input. Okay, and that's basically what we've got here. I am first instantiating a timer, an internal relay fault timer, and I've got a property, the time delay in milliseconds that the timer is going to go for. And then I've got my status values. Is the timer running? Has the timer expired? Has the timer need to be reset? Is a fault detected? And then the output of the trip signal. Okay, so it's basically all of these things we got here. And then I've got a constructor that basically sets everything to false. Now, you might ask, why am I instantiating the internal relay timer up here instead of in the constructor? I just do that because it's easier in terms of scope to have it available up in here. And in fact, when you instantiate the relay, it will first go and it will check this. We can verify that. So what I'm going to do is I'm going to put a breakpoint right here where I instantiate the relay, and we're going to see what happens. Okay, so I instantiate the relay, now I'm going to go into that method, and you can see the first thing it checks is it goes to this relay timer and starts a new, instantiates the timer. And then after that, it goes to the constructor. So it's nice, it knows enough to instantiate this timer. So basically I've got that, so I'm setting everything up, and then I've got a couple methods in here. I've got a few methods. And as we expected, there is a fault detector method, and there are two timer methods, one to start the timer and one to stop the timer. Okay, so the fault detector method, in my main program, I set the fault detected to true. You can use logic in here to determine if the current is above the value, but I just forced it into whatever that value is. So anyway, I've got, if the fault is detected, I say there is a fault. If the timer is not already running, I start the timer. So at this point, I won't go into detail on the start timer and stop timer. Pretty straightforward, but we'll come back to those. The thing I want to talk about now is the event handlers. So I've got the two methods, but as you can imagine, we need some event handlers, and we need event handlers to handle the two timers, the internal relay timer and also this system timer that checks the relay every 1/10 of a second or whatever, okay? So I've got two event handlers. This is one for the internal relay timer, and this is one for the system timer every time step, okay? So let's take a look at the system timer in this class, all right? So here's the system timer class. Now, one thing I want to mention, you may wonder, why don't I add this functionality to this main program? So let's say I wanted to add another method to this class program underneath the static void main. So let's say I want a public void test method, okay? and I want to put some code in here, maybe for a timer or whatever, and I want to call it from here. So if I do a test, you can see it doesn't even see it. So let's force it to see it. And you can see I get a squiggly, and the squiggly says an object reference is required for non-static field method or property program test. So you get into a problem if you're in a static void main here and you're trying to call a non-static method, it becomes messy. So what I like to do is I like to keep this very simple, this static void main, this program class, not add anything to it, and do that externally. And that's what I did with the system timer class. I made a separate class to get it away from all that static stuff where you need to, you can get into some problems. So I've got this system timer class, and the job of this again is to make a time step timer which publishes the time step events to all relay subscribers. In this case, I've got only one relay to subscribe. So I've defined a timer, and this is a system.timers.timer. And you can see I'm using system.timers, and I'm calling it run timer, and that's the tick timer every 10th of a second. And I've also got a property, the tick milliseconds, how many milliseconds between ticks. And that's a property with a get set. Now here, I'm defining a delegate and an event. And again, I encourage you to look at my 3-part series on events and delegates. But basically, this delegate says if you're going to subscribe to this time step event, you need to have a event handler in in this case, the relay class, that looks like this, which is a void and event handler, whatever you want to name it. And it takes in an object source and event args e. Okay, and if I go to my relay class, I go to the event handler, and it's a void, public void, object source, event args e. So that is the handler in the relay that handles each event, the time step event. And then it writes a console write line. Relay is receiving time step event notifications. And then you can add in whatever logic you need to check whether the current is reset or whatever. So now in this system timer class, I've got the, I'm setting up the delegates and the events, and I've got a couple methods. Actually, I got one method, and that is to set the timer, all right? And what that does, when you call set timer, it instantiates a new timer with the tick millisecond as the delay. Every tick milliseconds, it will raise an event. It starts the timer. I say run timer.enabled equals true. And then I subscribe that run timer, the event handler, to that elapsed event from the run timer, okay? So internally, I've got an event handler, which is this run timer elapsed, and it will get notification every time this run timer elapses, in our case, maybe 10th of a second. It will get the event, and it subscribes, so it will get the event every 10th of a second. And all it does is it calls this method below here, which is on time step. And so every 10th of a second, I run on time step. And what on time step does is it sends out the notifications to all the subscribers. In my case, I've only got one relay subscribing, but every time step it will say, if there is a subscriber, then invoke this event, this time step event, and send it to the subscribers. And at this point, the relay will get this handler, and it will console write line that the relay is receiving the time step event notifications, and then you can add this whatever logic you want to check the relay, and you're good to go. Okay, So I'm not going to go retype this. If you want to type this in, you can. But the point here was just to get some conceptual idea on how all this works. So what I'm going to do, go back to program, and I've got I'm starting up. I've got the relay set up, and I've instantiated a new relay. I've set the time delay of the relay to 10 seconds. So the internal timer, if it sees a fault, it starts the relay timer for 10 seconds. So it instantiates a new system timer object, system timer, and I call it time step timer, is new system timer. And here I set the tick milliseconds property of the time step timer to 1000 milliseconds or 1 second. You can make it a tenth of a second, you make whatever you want. And then what I do is I use the set timer property, which again, as we saw, starts the timer and generates an elapsed event. Okay? And then I subscribe the event handler for the relay to this time step event. All right? So the relay.timestep handler, which is this, I subscribe it to this every 1 second or tenth of a second event, right? So I've got the relay set up. I've got the time step timer running for every second. And then what I do is I just force a fault detected equals true and then run the relay.fault detector. So now if I run this, again, this is a console app, and remember, we forced a fault, so it says there is a fault. The timer started at 9:38 a.m. and every second it receives a time step event notification, and it times out after 10 seconds. And then the timer is disabled and the timer is stopped, but it keeps receiving these time step event notifications. So, if you have multiple fault events, or we've got the system timer that keeps running even though the local timer in the relay is shut off. Okay, so I think that's about it with this video. I'm not going to lead you through every semicolon and every line of code. You can pause the video, and I think I've got enough here that you can pretty much duplicate much of this. So anyway, hope that helps. Take care and have a really good day. Thanks.